Good evening, everyone.
Good evening, sir.
Good evening to all respected dignitaries, eminent resource persons, faculty participants, researchers, and dear colleagues. On behalf of Department of Civil Engineering, Sandeep Institute of Technology and Research Center, SITRC Nasik, I warmly welcome you all to the day 6, that is last day, and the concluding technical session of the AICT Atal sponsored online faculty development program on navigating urban climate challenges, sustainable solutions for resilient cities. This FTP conducted from 8th to 13th December 2025 has successfully brought together experts from IITs, NITs, and international universities, research institute, and industry to deliberate on climate resilient urban infrastructure, water security, and sustainable engineering solution. It is now my privilege to introduce our distinguished resource person for the today and the final technical session. Speaker of this FTP, Dr. Sahana V, a researcher, water risk modeler, water data for climate resilience research group, International Water Management Institute, IWMI, New Delhi. Dr. Sana V is a water resource engineer and a hydroclimatic researcher with a strong expertise in hydroclimatic extremes and drought risk, multivariate hazard and vulnerability assessment, non-stationary analysis in hydrology, climate change impact assessment, hydrological and statistical modeling. She holds a PhD in water resource engineering from IIT Mumbai, where her doctoral research is focused on droughts in India in a changing climate, multivariate hazards, vulnerability, and risk assessment. She also holds a MTech degree from SVNIT Surat and a BE from MSRIT Bangalore. Currently, at IWMI New Delhi, Dr. Sana is actively involved in regional and global climate resilience projects across India, Sri Lanka, Zambia, and Senegal, contributing to climate governance and water risk analytics. She has served as a primary session convener at AGU Fall Meeting 2023 and is currently a member of Editorial Advisory Board of Regional Environmental Change. Dr. Sana, just 1 minute. I will just give the some instructions to the participants. Then later you can take over the session.
Yeah, sure.
Actually, the session will start from now till it may get over by 6 to 6:30. So after this, actually, you will need to log into your what you say the Atal FDP, whatever the registration what you have done. So you have to go there and the test will be there, MCQ test. It will be of 25 questions, each carrying 1 marks, and you will be having around 1 hour of time. So that portal will be open for you to give the test is only 1 hour. Means 7 to 8 it will be only open. And before that, if you do also, it is not possible. And even if you try to do after 8 o'clock, it will not be possible, and you will not get the certificate also. And 70% of the marks you have to score in that. So if these two criterias and the attendance around 80% doesn't fall, then you won't get the certificate. And don't try to call and ask that try to do something to the coordinators or anybody. Nobody will can help you out. So this is a clear instruction from my side as a coordinator, because it is not in our control. The certificate is issued by the AICT Atal platform. So 7 to 8 will be the test. So please keep it in your mind, and that has to be answered through your login of your Atal FTP login what you have, from where you have done the registration. You have to go there. First, you have to fill all the test from 7 to 8. Immediately after giving the test, you have a feedback form below that. So once you do the feedback form plus the test, then automatically, if you have a attendance 80%, then automatically the certificate will be generated to you. Okay. So Dr. Sana, you can take over the session. You can upload the PPT and you can start the presentation.
Yeah, thank you, Prashant. I'll share my screen. I hope the My screen is
Yeah.
visible.
Yeah, it is visible. You can make it full screen.
Yeah. Good evening to one and all present in today's session. First of all, thank you, Professor Prashant, for my introduction. Today I'll be talking on the assessing the rarity of drought events in India using multivariate standardized drought index and Hoopla-based severity, duration, frequency curves. I would like to acknowledge for this work my PhD supervisor at IIT Bombay, Professor Arpita Mondal. Coming to the introduction. So what are droughts? We all know that this is a naturally occurring extreme event, which is mainly caused due to the lack of precipitation. And also the droughts have the highest impact affecting multiple sectors across the society and across the globe compared to other natural hazards. So droughts stand among the first ranking when it comes to the number of people getting affected due to the hazard condition. And coming to the impacts in India, for example, the 2002 drought that occurred, it had a huge impact on the agricultural contributions, where the GDP during that year dipped by 3.1% by a study noted by Down to Earth 2015. And in another drought that occurred in India in the year 2015, the 91 major reservoirs in India had dipped to their minimum levels, and there was only 24% of water that was left in India's key 91 reservoirs. And the drought that recently occurred in the year 2018, there were around 500 million people that were severely affected during this drought condition across the country. And also mainly the peninsular agriculture and drinking water availability were also affected during this period. So it is important that drought monitoring, whether it's operational or long-term risk assessments or for early warning, it is very important for India to appropriately characterize drought, monitor them, and manage them. Now, coming to the classification of droughts, the drought is mainly occurred due to the lack of precipitation. So the precipitation deficit, the precipitation deficit mainly causes the meteorological drought. So if we have the precipitation data, this drought can be characterized. And further going in the hydrological processes, the precipitation deficit may cause a deficit in the stream flow, and that is where the hydrological drought would occur. And this is mainly due to the surface and subsurface water resources deficits. And here the main drought indicator is the stream flow variable. Apart from the stream flow characteristics, the geology and the surface conditions, surface and subsurface conditions of the region also affects this particular drought condition. Then further in the hydrological processes, further to precipitation deficit and the stream flow deficit, there can be a deficit in the soil moisture also, and this is called the agricultural drought, and this leads to the subsequent crop failure. And next, the socioeconomic drought. So this is mainly associated with the deficit in the reservoir water. So the downfall of water resources system would mainly cause the socioeconomic drought, and this will greatly impact the supply and demand of water in a region. So this is mainly experienced for the mainly alters the reservoir operations during this time, the socioeconomic drought. And also there is there can be a groundwater drought when there is a decrease in groundwater discharge, where there is no enough water to pump in order to meet the needs of the needs of water, whether it is agriculture or domestic supply. And here the main drought indicator is the groundwater level. Now coming to the drought indices. So what is a drought index? This this value is typically a single number that is much more useful than the raw data for decision making. So this is the definition given by Hayes in 2002. Now, how do we assess drought? This is using the by defining the drought parameters from the drought index. So any drought can be characterized using its parameters like the intensity, the duration, the severity, and how much spatial extent has been covered during the drought. And what are the major requirements for computing this drought index is mainly the drought indicator, whether it's precipitation drought we are interested in, or the soil moisture drought that we are interested in, or the socioeconomic drought that we are interested in. Accordingly, the drought variable is considered for a long time series. Typically, we will be going with the monthly accumulation values of these drought indicators. And if we are dealing only with a single drought variable, whether it's only precipitation, whether it's only soil moisture, then it is called as univariate. Then what we get is the univariate drought index. And with one or more drought variables are considered at a time to characterize drought, then we will call it as the multivariate drought index. So once we have those drought variables, what we typically do is fit